questions about any of those before we start?
Yeah.
I'm meeting today, but I'll be here tomorrow.
You said Monday we're meeting after school?
Yes. Tutorial on Monday. We're good? Questions? Okay, we'll get started with the spark. Are these forces balanced or unbalanced? Brianna, what do you think? Why? Okay, the schema. What is an object? What are the objects in here? Chisholm, what are the objects?
The box, the string, and the roll.
Box, the string, what was the last one?
Roll.
Four. Okay. What are the forces between each?
Box, the string would be tension, and then box the floor would be gravity, and then floor box would be roll force.
Okay. Good. The free body diagram. Yeah.
Okay, at first when I did that, I had all in until I got the E and it said the FL. So that's when I added friction.
Okay, so why would there be friction?
Because the box is going across the floor.
Good. Good. Alright. Free body diagram. What's it kind of look like? I'll give us the box. Mercedes.
Going down FG, going up FN, to left FL, and a 35 angle FT.
Questions? Chisholm.
Okay. Why isn't there any applied?
Where would apply come from?
The spring to the box.
Okay, so what kind of force comes along the string?
Tension.
So where would the apply come from? So the force that you're thinking about, like you would say that the string is applying a force to the box, but the kind of force is the tension force. Does that make sense?
So you can have tension inside.
I mean, not from the same object. The string is going to supply tension. If I started to push it from the other side, then I would be making applied. But the string's only going to give tension.
Okay.
Okay?
Mm-hmm.
Okay, component diagram. Devine, what are some component diagram parts?
Is this where we have to use X and Y?
Mm-hmm.
Alright, so it'll be F and X, right?
F what?
F and X, is that one?
Is FN moving in the X direction at
Oh,
all?
no, I see the Y.
Okay, so what's FN
So it'll
moving?
be F and Y.
Okay. Yeah, so it's just gonna, just Part D, this is the part where it gets more interesting. Part D, what does FG or FGY have to be equal to if this is balanced? Kaisha.
You said what is FG?
Mm-hmm.
FN
Mm-hmm.
plus FTY.
Good. Why?
Because FTY is a part of FN. Because they're both going up.
Because they're both going up. Okay, they're both going up, so why does it have to equal what's going down? You're right, I'm saying, if these are both going up, they have to equal what's going down. Why? Because, okay. And then the last one, what does FF have to be equal to? Money, what do you think?
FF equals FT?
FT, just FT, this one?
FTA.
Why?
Divide.
To balance it. That means what about these two arrows?
Yeah, same magnitude.
They have the same magnitude. Good word. Very good. Okay. Questions about this? This is where we should be at based on what we did last week. Now we're going to move on to friction. Okay, get some stuff out to take notes while I erase. We'll talk about friction. Way back, something like a month ago now, when we started this unit, we talked about the definition of friction force. What did we say friction force was? It's in your notes somewhere, a long time ago. What is friction force? What do we define it as? Brianna's looking at her pocket. It's probably her choice. Friction force. What is it, Brianna? Good. Everybody hear her?
Mm-hmm.
Alright, so friction is the resistance to movement force. And what we're going to learn today is that it's based on the normal force. Okay? We're going to go through this. We have what we're going to call the coefficient of friction. Okay? So you already have the definition of friction. Friction, resistance to movement. And it is equal to, the formula we're going to use is friction force, which will be F, is equal to what we call mu times the normal force. What is what?
How do you draw?
This, okay, so it's like a U, but with longer legs. It's like a cursive U, and it's called mu, and it's one of our extra fun Greek letters. Okay? Mu is mu, which is our next note anyway. Mu is equal to, we say it mu, like moo, but better. Alright? And it is called the coefficient. Sometimes I can't spell this word. Of friction. Alright, so let's talk about what the coefficient of friction means. Coefficient of friction is a number, right, assigned to a surface that says to us as physicists how much that surface wants to hold on to an object. Okay, so it's the coefficient of friction tells us how much, so it tells us how hard, I don't want to say sticky because that's not a right word, how hard, how much a surface wants to hold on to an object. Okay, so to give you an example, Velcro would have a huge coefficient of friction because it wants to hold itself. It's very hard. Whereas the whiteboard, not so much. All right. Questions about coefficient of friction? The larger a coefficient of friction, the more hold the surface is going to have on the object. Okay? The larger the coefficient of friction, greater hold the surface has on the object. Now we're going to talk about Fn. We're familiar with Fn. What is Fn? What does that mean? What is the normal force? Chisholm?
Pushing back.
What's pushing back? So if I am pushing on the floor,
Force pushing back up. No. Yes.
the force pushing back up. Okay, so Fn is the normal force. And it, in this equation, tells us how hard the surface pushes on the object. Okay, so this equation, friction is equal to mu times the normal force, is saying friction is equal to how hard the surface is pushing on the object times how much the surface is holding on to the object. So it's about how hard it's going to be to move whatever is moving. Mercedes.
Okay, you know how friction is, mu is the larger mu is the greater hold on the surface. Really true about the scenario.
Right, so the bigger, looking at this equation, the bigger the normal force is going to be, the bigger friction is going to be. Does that make sense? So the bigger the normal force is, the more that the surface is pushing on the object, the bigger friction is going to be. Other questions?
Tuesday, which is not Monday.
Okay, we're going to do some examples then to kind of get this sorted in our brain. We have two boxes. We have a box sitting here of 10 kilograms. companion box sitting here, also of 10 kilograms. The coefficient of friction of both of these are the same, right? Coefficient of friction on both of these is the same. We'll say 0.5 for the sake of argument. If I am pulling this box this way, and I'm pulling this box this way, which one of these boxes will have the greater normal force? And then,
The first one,
why?
because the second one's being pulled more north. So it's taking more, normal force off of it.
Good. It's taking vertical force.
Right.
Okay, so over here, we're gonna have Ft, right? Fn, friction. What's Fn gonna be equal to over here? Mercedes?
Empty.
Good. I really don't know why this marker is. Okay? Over here, we're gonna have our component diagram, and that's gonna look like what? Okay, shit, what's this gonna look like?
Tension will go from to the right,
Mm-hmm. What else is on here?
FG, FN, and F.
What's normal force gonna be equal to over here then? Mercedes.
Fn plus Fty.
Well, what's gonna be equal to Fn plus Fty?
Ft.
Okay, we'll start there. Fg equals Fn plus Fty. So what's normal force gonna be equal to? How do we rearrange this? Devine, how do we rearrange this for normal force?
Mg minus Lt1.
Good. Okay. So we're showing that normal force is less on this one, which means the frictional force is going to be less for which one, if the U is the same.
So,
What, Devine?
for the second.
Why? Friction is equal to mu times normal force. U is the same. So why would this be less? What's less in the second?
Tension.
Okay, that's fine. You told me friction's gonna be less, right?
Yeah.
Mu is the same. So what has to be true of normal force?
Is that what it is? I don't know.
Devine,
Just tell me.
I'm not telling you. You're gonna figure it, listen, you're gonna figure it out. Between these two, you said friction is less over here. Normal force is less. Because U times normal force equals friction. If U is gonna be the same, normal force has to be less. Okay. So, a conclusionary statement that we need to write. What would you say? If I said, tell me in words what's gonna happen, what would you say? A sentence. What Devine just told us, but make it a sentence. Occasion. Make a sentence. Summarize what just happened. Which friction's gonna be less than which one? Why? our sentence would be friction is less in the second scenario.